So Feistel Network for block ciphers and for symmetric block ciphers. Feistel network is very important network. Based on this particular Feistel network, so all block ciphers have been implemented. Out of those, very important block cipher is DES, so data encryption standard. షఫియోరు అంతేనా అంటే ఏంటో నాకు అర్థం కాలేదు. Okay, data encryption standard. This data encryption standard was used approximately some 20 years. For 20 years, DES has been used by all crypto systems across the US and European Union. Many places, the DES has been used. Within the DES, internal structure has been designed by one German physicist, not mathematician, physicist, is Feistel. Okay, so this is very important for us, and it is a symmetric structure which is used to construct the block ciphers. Block cipher in the sense, so data can be taken in block by block. For example, this could be the data. This amount of data is there with you. Previously, we have taken character by character or bit by bit will be taken, and they will be manipulated accordingly. But right now, so huge amount of data is available, something like this. This huge amount of data will be divided into blocks. Already we have seen in the previous classes. Blocks. Block size will be either 64 bits or 128 bits or so 512 bits, something like this. If any block is not supported this much amount of data, you have to fill with some lag bytes, lag bits. So based on that, you have to prepare completely, which is satisfies two power value. So something like this will be taken into consideration. Most probably, DES will be work on 64 bits. Okay, we will discuss this DES by tomorrow onwards. Probably it will be taken some 3 hours to complete the understanding of DES in our cryptography here. However, so it has been introduced by one German physicist, Horst Feistel and Don Coppersmith. These are the two people who introduced this particular Feistel structure or Feistel network in 1973. When they are working with IBM, they have introduced this one. They did approximately 4 years of research on cryptography, and finally they have emerged with Feistel network, which is very useful. And this Feistel network still people are using. So across European Union, so there are certain electronic passports are there. Electronic passports are using still DES only. Electronic passports are using DES only. And electronic, what do you call, they do have, as like as our Aadhaar card, they have for the permanent number. So SSN number, that's also be used with the DES only. Okay. However, when exactly this need has been emerged here to identify the Feistel network is, so NSA, National Security Agency of US federal government has ordered to, or requested to IBM to prepare any security standards. Before 1973, in the public domain, there is no security. So we do have some kind of security issues in the private domain, but in public domain, there is no security issue. So this Feistel network or DES can be spanned for 1973 to up to 1995. People are used this particular DES for their what do you call, security crypto systems here. Okay. However, the emergence when it was created and when it was got created here in the sense by NSA has requested to IBM to prepare a good crypto system, so that host the Feistel and Coppersmith, these people have worked together and come up with one particular Feistel network in 1973. And basically, the advantage of this particular Feistel structure is so encryption and decryption. These two operations are identical. These two operations are most identical, and these two things are supposed to be encryption or decryption can be used same key for doing such kind of encryption and decryption. So that is why it is comes under symmetric ciphers. Okay, symmetric block ciphers. Okay, and two more people. Okay, two more people. So Michael Ludi and Charles Rockoff. These are the two people in 1975. What Feistel and Coppersmith has prepared, they have they have re-verified and proved that cryptographically it is a pseudo-random function, and three rounds of Feistel structure will be gets operated on block cipher. It could be enough. If you go ahead with one more round, that is fourth round, so the cryptography, otherwise the security is more and more strong than any other crypto systems during these days. So it is following the pseudo random permutations in Feistel network here. It has been proved in 1975. Thereby, people are using this particular Feistel structure in many so crypto systems such as so DES, triple dash 3 DES, AES, Blowfish, and so on and so forth. Many other crypto systems have also used this Feistel structure only. That is the power of this so Feistel network here. So what is the exact operation which could be done here in the sense? Feistel network is having some iterative kind of nature, and a function can be used which is called as a round function. A function f of something, f of some k or something, some x comma, so some k will be taken into consideration. Something like a function can be used here. And this function is always used to perform with exclusive or of another parameter here. However, these two operations could be took place in Feistel network. So this round function is very important for us, and this round function will be plays a vital role in Feistel network here. And because of this round function, because of this so exclusive OR operation, so it is very easy to construct the hardware of a crypto system. It is very easy to construct the hardware of this crypto system here. So this is a basic introduction towards the crypto, Feistel network. Then how it could be. Basically, in 1973, these people, early 1973, these people have a thought to prepare the encryption. Something seems like this. They have taken a block of so plain text, something like this, and this will be sent to the round function f of k. This will be taken two different types of single parameter will be taken into consideration here. So normally any function, whatever the function it may be, for example, that function might be, so either it is unary function, or it is binary function, or it is ternary function. Three different types of functions are available. Let me say operators are available in computer science world. Unary in the sense single parameter will be taken into consideration. Binary in the sense two parameters will be taken into consideration. Ternary in the sense three parameters or more number of parameters other than three. Okay, three or more number of parameters will be taken. That is called as a ternary. Ternary cannot be used in our crypto systems. Ternary cannot be used in our crypto systems. So either it is unary or it is binary. Either of these two can be taken into consideration. So initially, Feistel and Coppersmith has been think that they have taken unary operation. Look at this. This function has been taken only single parameter, that is ki. There is no other parameter here. So binary operations are not supposed to be done here. So plain text will be taken, and this function, the key will be taken into consideration. Plain text and the key will be exclusive odd. Therefore, cipher text will be gets prepared. ciphertext will be gets prepared. So this area is called as mixing or mixer. Of course, it has been considered as exclusive OR operation, which is called as mixer. So therefore, so ciphertext will be gets prepared here. And in decryption kind of issue, same kind of so ciphertext will be. I mean here C1 and C2 will be same because this data will be transmitted over internet here. It has been received by the actual receiver. So during this particular time in internet processing or transmission time, if there is any modifications, those modifications could not be taken by this decryption here. So that is why what exactly we would like to consider here, C1 will be equal to C2. That is the meaning here. However, whatever it may be, what exactly it is being done here in the sense. So here on plain text, so we have been operated a mixer here so that we have prepared C1 from the encryption algorithm, whereas in decryption, same kind of operation which has been done by on ciphertext, so that we would like to get that plain text back here. Okay, it is initial design which was made by the Feistel and Coppersmith. It is the initial design. So after taking this particular design, they have observed so much strongness in terms of crypto systems is not there, because the function, the round function which has been took place here will be taken single parameter, and it has been displayed single parameter only. So taken information and displayed, I mean return the value. So therefore, so the key, if people will be know about particular key, then immediately we would like to have this plain text back. So without doing any other extra operation, so that so in the beginning days, that they have in the early 1973, John Phibb or 1773, they have created something like this and observed. So it is not good enough. However, what exactly the point will be here? So f of k will be taken. So the key for doing some kind of so non-invertible operation by this round function here. And secondly, so in mixer, what exactly we are trying to do? Exclusive odd on plain text in terms called as so ciphertext. After exclusive odd will be happen here, then the output from exclusive OR operation, then it will be produces a ciphertext here. Okay. Then encryption and decryption, same key can be used. Whatever the key you have used here, the same key can also be used here. So that is why we have mentioned Ki and Ki here. So same key can be used to perform the encryption and decryption here. So, and here ciphertext 1 and ciphertext 2. Actually, we have to mention C and C here. We have to mention P and P here, actually, as far as the point is concerned. But after creation of ciphertext, it must be transmitted through so insecure channel, let me say internet or any other insecure channel here. So because we have processed this one through insecure channel, there may be a chance to disturb that particular ciphertext if things will be not do in a proper way. Okay. So that is why we have mentioned as C1 is equal to C2 if transmission could not be performed any extra operation on the ciphertext which have been prepared in the encryption algorithm. Okay. So that is why if these two will be gets equal, for example, C1 will be equal to C2, if these two will be gets equal, obviously after decryption, so the plain text which have been actually taken by the sender and received by the the receiver or recipient will be same. So to justify this answer, that is why we have taken into consideration that yes, C1 is equal to C2. Okay, even then the transmission is being happen in insecure channel, there must not have any attackings on C1. So that is the meaning here. Okay, that is the meaning why we have mentioned or termed as C1 and C2 here. Okay. Then after so first quarter and second quarter, they realized that yes, the function round function has been taken only single parameter or single argument, so that so-called so operations will not be that much strengthened. So that how that has been implemented here in the sense. So whatever the data they have considered here, this particular data will be divided into exactly two halves. So if 64 bits will be taken into consideration, L1 will be equal to 32 and L2 R1 equal to 32. So this will be, for example, I am talking, for example, this could be 32 and this could also be 32. 128 will be taken into consideration. It is 64 and it is 64. Like that, exactly equal halves. Your plain text will be divided into exactly equal halves, and round function will be changed a bit. Let us observe. Round function will be taken. Right half will be one of the parameters of round function, and of course, key will also be another parameter. Key will be also another parameter. Look at this. Key will be one parameter, and the round function, the right half will be second parameter of this round function. So look at this. It has been taken from this round function. You please try to observe whatever the R1 value, that R1 value has been directly passed to R2 in ciphertext. This is actually ciphertext. This is actually plain text here. You please observe the input for encryption will be plain text and output of encryption algorithm will be ciphertext here. This is the ciphertext. So there is no modification in terms of R1 and R2. R1 will be directly processed with so R2 here. Okay, but L1, so how this could be done here? So a key has been taken into consideration and the entire R1 will be taken into consideration. It has been performed some kind of operation. What is this operation? Let us know in DES, not exactly here. So we are not supposed to concentrate here. After this one, L1 will be taken into consideration and output of this round function will be exclusive OR and it could be processed through so L2. L2 cannot be L1 as like L2 cannot be L1, but R1 can be exactly equal half of so R2 in ciphertext. Okay, for example, this is plain text one. Let me say this is P1 and this is P2. For example, if two halves will be taken into consideration, if it is P1 and P2, plain text one and plain text two, for example, it will be taken into consideration something like this. Otherwise, let me also consider not like this. So this is plain text at the left side, plain text at the right side. For example, if you consider like this, so whatever the plain text at the right side, that could be carried with the ciphertext at the right side. For example, here 0, 0, 0. For example, so for example, it could be 0, 0, 1, 1, 0, so 1, 1, something like this. Same data will be transmitted here also. 0, 0, 0, 1, 0, 1, 1. Same kind of item will be, same kind of half will be transmitted to so ciphertext at right side. Whereas ciphertext at left side, CL, so it has been performed many operations. Look at this. So if it is 0, 0, 0, 1, 1, 0, 0 will be there with us at left side of this one. After performing, after taking this key and after taking this particular value, what is this? So right side value of the plain text and perform some kind of output. Let us consider this output will be 0, 1, 1, 0, 1, 1, 1, 0, something like this. After this one, these two will be exclusive odd and we will get 0, 1, 1, 1, 1, 1, 1, 0. It is only example. I am writing so vaguely, so like this. So the input what we have taken will not be the same here, will not be the same. But the right side of plain text will be exactly copied to so right side of ciphertext. So what exactly you are giving indication to the hacker here? In through hacker, what exactly we are supposed to give here is 50% of data will be as it is within the plain text. 50% of data will be same from the plain text here. That is the meaning here. And the first 50% will be mixed for several times. And finally, you could get some other kind of a ciphertext and you could identify what exactly that, then your plain text will be back. Okay. So this could be the modification they did in second quarter of 1973. And decryption also be done in the similar fashion. Decryption, there is no difference at all. So R3, whatever the, let us consider this is the ciphertext at right side, this is the ciphertext at left side. What exactly you are supposed to do? Ciphertext at right side will be, so as it is of plain text of right side. So that could be directly sent to plain text of right side at a decryption level. So there is no modification. You are not supposed to do any kind of operation on this one. You must be perform the operation in reverse operations on ciphertext at the left side. That's what you need to perform. So that is why you have to take a key as input, and you must be take the ciphertext from the insecure channel. So right side of the ciphertext will be taken. Afterwards, whatever the output it might be get, that output will be sent to exclusive R, and you will get the plain text. I mean, so this is a plain text at the receiver side left, and this is a plain text at the receiver side R. Okay, so look at this. It will be directly sent to plain text at the receiver side R. There is no so modifications here. Modifications will be happen at left side only. At left side, your modifications could be done here. So therefore, it is also somewhat insecure because 50% on right side of the 50% data, you did not perform any kind of operation. Directly, you have to send to ciphertext, and directly you have to send it to, so in decryption directly, the right side value could be sent to the plain text. So hacker will easily identify that yes, 50% is so just okay. It doesn't make any kind of sense on encryption or decryption here. So only 50% will be evaluated by you. Obviously, you could get the plain text back. So this is what they did in second quarter of 1973. But this is also so not satisfied with their work, and afterwards, okay, some data will be there here. We would like to see that particular data here. So what exactly those people have identified within this particular thing here. So both left side and right side, okay, left side and right side will be taken into consideration. Two different types of input. Plain text will be divided into two equal length blocks, that is left and right here, and the right block will be so input for round function, second input, second parameter for round function, and first parameter will be as it is, that is key. Whatever the key you are expected to take, that is second one. So therefore, if you perform some kind of operation at this level, so key will be get strengthened. They even then key will be get strengthened. So 50% of data is not so what you call mixed, or let me say that is not converted into actual cipher. That is as usual, which will be there with plain text will be sent here. So that is why it is not that much stronger. Of course, left block will be as usual. Previously, what we have discussed, the same thing will be taken into consideration here. And whatever the discussions we made just before, the same encryption and decryption could be used the same kind of key, and encryption decryption algorithms will be inverse mode each other. So here plain text will be taken and perform the round function. Here ciphertext will be taken and perform the round function here, something like that. That is why they are so inverse to each other. That is the meaning. Okay, let me explain this one after some time. Let me explain how this could be get. Let me explain after some time. You please observe here we have concentrated on L4. Look at this. This is the left side of decrypted plain text here. We are concentrate on only L4. We did not. What is the information about R4? We don't have any information at this place. We don't have any information. We don't have any equation at this time. So therefore, 50% will be same, and second 50% will be so encrypted or decrypted here. Remaining everything is same. Okay. So that is the so second quarter output from so Feistel and Coppersmith. Okay. So to strengthen this one, what they did, let me go ahead with other. So Feistel Network. So finally, what they did here is they have introduced one more. Look at this previous one. We don't have any one more extra box here. Directly, this is ciphertext is there, and plain text and the mixer will be there. But here we have taken one more extra box here. This is big box. This is the mixer. And one more thing, this is the swapper. Okay, finally, this is the ciphertext. This is ciphertext. Okay, look at this. What exactly these people did in the final way of the conclusion of Feistel Network here. What they did here, this is the final conclusion. Look at this. So similarly, what exactly they have did in second quarter, here also did the same, but one extra operation will be took place here. One extra operation will be took place here. Key will be taken for the round function. And of course, previously, what exactly they have taken, R1 will be one of the, right, plain text will be one of the inputs of this round function. Key will be second input. And whatever the output of this round function, so that could be exclusive OR and it could be send. Look at this. So left side exclusive OR mixed item will be sent to so right side of next ciphertext. Look at this. So here L1, okay, L1 will be mixed continuously. This mixed operation will be sent to right side, and R1 that is sent to the left side. Okay, previously R1 has been sent R2 directly, and L1 will be applied exclusive OR and mixed for several times and will be sent to L2. So previously, but right now it has been swapping. If you go ahead with second round, one more round will be continued here. Now R2 will be sent as it is, but L2 will be mixed here. Previously L1 has been mixed and it will be sent to R2. R1 has been, it doesn't mix anything. The data, for example, it is 0, 1, 1 will be there. So from round 1, 0, 1, 1 will be the 1, 1, 0, 0, 1, 1 will be the value of L2. And here, so 1, 1, 0, 0 will be the value of L1. So after doing this particular operation from round function and exclusive OR, it could be 1, 0, 1, 0. For example, it could be taken. So round R2 value will be 1, 0, 1, 0. Okay, it has been applied some operation, but whatever the right value, that doesn't take any change here. Now, if you go ahead with second round, so look at this. This will be so sent to the round function, and this 0, 1, 1 will be mixed, and 1, 0, 1, 0 will be sent as it is. So therefore, if swapper could be included, swapper could be introduced into this Feistel network, obviously, so for people will be goes with 3 rounds or 4 rounds. In the first slide itself, I have shown that so Loeb and some other person, Michael Loeb and one more person, I did forget that particular name at this moment. Those 2 people have identified that if 3 rounds will be taken, so Feistel network is very good enough, and 4th round will be taken, obviously it will be goes for strong cipher. Okay, so that is why previously R1 will be sent directly to R2, L1 will be mixed and sent to L2, but right now it is not the case. R1 will be sent to L2 directly, L1 will be sent to R2 directly. If you take second okay, if you take second case, second round, L1 will be converted as, so here it is L2, R1 will be converted as R2. Look at this. Previously, as per the round number 2, R2 will be equal to actually, so encrypted value of L1 here, encrypted value of N1 here. But L2 will be equal to directly R1, sorry, directly R1. Now you have to operate encryption on this one. It will be as it is. There is no modification here. There is no modification here. Nothing will be done here. Okay. In this way, if a number of rounds will be go through by this particular encryption, then entire data will be so encrypted like anything. Therefore, the things will be happen here. In decryption also, we would like to perform the same. In decryption, look at this. So L3 will be sent to R4 directly, and so the operations will be done in similar way. Operations will be done in similar way. Look at this. So if this also be taken 3 rounds, how the mixing will be happen? If this will be taken with 3 rounds, how the mixing will be taken? Previously, how many number of rounds you will be taken? R1 will be always assigned to right side only. L1 will be encrypted, encrypted, encrypted for several number of times, or 3 times or 4 times, something like that. R1 will be same. There is no change in R1. But right now, first round, R1 will be sent to L2, and L1, encrypted L1 will be sent to R2. In second round, encrypted R2 will be sent to L3 directly, but L2 will be encrypted again, and that could be sent to R3, and so on and so forth. Let me draw a diagram for you. For a while, it is very easy to understand. Let me draw empty place. Empty space will be taken into consideration. Then let me draw here. So your plain text will be seems like this. So here it is, first part and second part. So you have taken some so round function here. So it is directly sent to a swapper, and it could be perform some kind of operation here. After getting operation, it could be sent to swapper. What swapper could be done here in the sense? Swapper could be swap like this. Okay, now your data will be again taken into, so previously one will be sent to this area. This is encrypted of one here, and this is two directly. Now what exactly we are trying to do? So you are trying to perform this particular operation. You are trying to take this mixer operation. Now you have to mix this one, and this will be directly sent to swapper. So this mixed will be so taken something like this. Now it could be sent like this. So previously, what exactly this one here? This is encrypted of one will be taken directly, and now it could be encrypted two will be. Look at this. So both will be encrypted here. Both will be encrypted here. So in the previous, for second quarter output will be one part will be encrypted, second part will be same. But right now, because of this particular swapping operation, this particular operation, so if you increase number of rounds, both will be gets encrypted for number of times, so that it could be somewhat stronger when compared to the previous experiment here. So in this way, it has been done. In this way, it has been done. So in this regard, DES has been taken 16 rounds, not exactly one or two. 16 rounds will be taken by DES. So because of 16 rounds, DES is very, 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 very strong. Okay, remember. Let me erase this one, and I will show you the complete diagram here. Okay, look at this. Key has been taken, and function key could be provide some kind of output that could be exclusive out by L1, and L1 will be so forwarded to right side of the cipher, and R1 will be forwarded to left side to the cipher. Okay, this could be round number one. This is exactly first round. Same thing could be, so based on these two, this particular value, if you perform round number two, some more encryption. Round number three, extra encryption. Round number four, extra encryption, and so on and so forth. Many number of times encryptions are being happening. In decryption, of course, it is mixer and it is swapper. However, in decryption, what exactly been happen here in the sense? So L3 will be directly sent to this one, and finally it could be performed. Quite opposite operation will be took place here. So what exactly you need to consider? For example, if DES will be taken, DES will be taken 16 rounds in the sense. At encryption side, this is round one. At decryption side, this is the 16th round, 16th round here, round 16 here. Okay, you please understand. So here number of rounds are being happening. So around 15, 14, 13, something like this, all things will be happen, and you got this particular ciphertext here. Then this could be finally you have to perform this one, and you get plain text back, something like this at decryption side. Where encryption, this is the round one, round two, round three, and so on. Round 16 will be happen. After 16, whatever the text you have with you, you have to send here. That could be done. In this way, Feistel network is being happening, and this Feistel network will be took place here. Okay, this is what about the Feistel. This is very, very important, and it will be comes to you for final examinations for 8 marks. Explain the complete Feistel network, so that it will be comes to you for 8 marks here. Very soon I will forward this material also to you. Okay, the time is also going to up. Okay, so this is what for today's class. Okay, follow the timer.